Pathfinding. Oh, pathfinding. Maybe you're making an RTS game like Age of Empires, or you're making a colony manager like Rimworld or Oxygen Not Included. Or maybe you're just making a simple platformer, but your enemy keeps hitting a freaking wall every time it tries to follow you. Well, my name is Matt, and welcome back to Mathantastic Productions. And on this video, I'm gonna explore pathfinding and try to develop one myself on this new series I'm calling Let's Go Together. When I first decided to get into this project, I had no idea what I was getting myself into. I had no idea if it was going to be hard or if it was going to be very easy. I honestly had no clue how to make a pathfinder. So I had to sit my ass in a chair and study for a while and try to figure out how the hell do I do that. While doing my research, I came across this thing called a weighted graph. A weighted graph is made by nodes. Each node is connected to other nodes, and this is what the pathfinding algorithm uses to navigate the space. So the first thing I needed to implement was a weighted graph. To make a weighted graph, I first created a bunch of nodes all across the map. All of these nodes were connected to their neighbors with a class I created. I then deleted all the nodes that collided with any wall, and for the weights, I used 10 for the straight lines and 14 for the diagonals. So now the map was all connected with nodes all across the walkable areas. I then made a player game object and a script that would move him through the nodes just to test if all the nodes were working. After that, it was time to implement the actual pathfinding algorithm. So I researched a bit more and I came across this Bowman-Ford algorithm. The Bowman-Ford algorithm searches a weighted graph and gets the distance between one point to every other point in the graph. I thought it was a good way to start develop the Pathfinder, but it ended up being quite a terrible idea, but that's what I went for anyway, right? So I watched this video on the Bowman-Ford algorithm and read some articles about it, and I ended up being able to implement it quite well. But my map was too big and it would take a really long time for the code to go through the entire map. I actually did the calculations and theoretically it would take 4 hours and a half to do it. So it wasn't pretty usable, right? Like if I limited the max distance to 10, then it would work fine like I'm showing right now. But I needed to calculate the whole map, so it was pretty clear that this algorithm wouldn't really work. So after a couple more hours of researching, I came across the A** algorithm. It is a variation of the Dijkstra algorithm, which is very similar to the Bowman-Ford. The only difference that the A* looks for the distance between two specific nodes, not the distance from one node to every single node in the map. So it goes through the least amount of nodes possible, which is perfect to run it quickly, right? To really understand the A* algorithm, I watched this video from Sebastian Lang. It really explained the theory perfectly. I didn't watch the rest of the series because I wanted to implement it by myself. I only checked out the video to understand the theory, right? But in simpler terms, the algorithm starts at the starting node, and from that it searches all the nodes nearby and gets 3 variables from it. The G is the direct distance to the beginning node. The H is the direct distance to the final node. And the F is H plus G. The algorithm calculates all the 4 neighbors of a node and runs the function again to the node that has the lowest F cost on all the nodes they looked into. This makes sure it goes through the fewest amount of nodes possible to get the closest path to the destination. After that, the algorithm traces back from the end node to the starting node to create a path. So I created this graph. On this graph, the black nodes are the nodes that were looped through. The cyan nodes are the ones that were calculated, but their f-costs were too high, so they didn't actually ended up being looped. And the yellow nodes are the nodes that were traced back as the path to the end node. After that, it was simply implementing a script that would go through the paths and move the player, and the pathfinding was done. I put some fancy graphics I found on the asset store just to make it look a little prettier, and it's done. There are still some things I'd like to add to this. For example, the algorithm doesn't use diagonals, which makes the movement very stiff and weird, but for now, it's good. So, this is the video, guys. Thank you for watching till the end, and like the video and comment if you want to see more videos like this, cause I'll read them all. So this is it. Hopefully I'll see you all next week. Bye.